is going to talk about how to streamline heterojunction. So with this, Mr. Dirk, sir, the stage is all yours.
I hope also to see that. Yes. Thank you so much. I make you today to expert of PVD coating. Yes. And now what we want to discuss today, you have seen that slide there also there before. I was talking about it. PERC is phasing out. Two technologies are really there on the rise. One is there the TOPCon, the other one is there the heterojunction technology. And I just want to explain to you there how to make the heterojunction technology they're very competitive in the market, also there in India. Because you hear they're also there in the market, okay, the heterojunction compared to the PERC, to the TOPCon technology is CapEx-wise as well also there on OpEx-wise not there. How to make that? Because we see there also a lot of potential in the heterojunction technology to reduce really there the cost of ownership and also to increase there the competitiveness in the market itself. But how do we do that? And this, I just want to show you a little bit about it. The price differences on cell, or let's say the cost of ownership differences in comparison to TOPCon is roughly 25%, yeah, in the cell, on the cell. When you're looking at completely the whole downstream to the field installation, all-in costs, then there is no differences anymore. Especially there also the LCOE cost on heterojunction is a little bit better than on the TOPCon side, but the cells are still, they're also there with the gap. And a lot of people, they are still challenging there and saying, okay, I go for the mainstream, then therefore for the TOPCon technology. What can we do there? And there I will take a few minutes of today to take you there with me, yeah, to show that what you can do, especially there also with the PVD technology. Okay, we talked about that I'm from the company from Modena. We have the booth on the German pavilion in Hall 11. Please come to us there also and talking with us. I told you there already that we are located in Dresden. We have manufacturing places there in Germany as well also there in China. We are around 1,300 people and also family-owned companies, similar like also there the speaker was presenting there before. We have locations, our locations there in India, Malaysia, Vietnam, in China, Japan, USA, and also there in Germany. And when you're looking for the products, what we already there delivered to the N-type market, crystalline photovoltaic market, with our equipment are produced around 72 gigawatt on products. So 35 gigawatts on the N-type market and 37 gigawatt then therefore for the thin film market. I explained you there also then this morning that Fornadene serves with its equipment their different, let's say, areas of technology and also they are in scaling, yeah, and the heterojunction technology as well also there the TOPCon technology is already there really in mass production available there in the market. IBC comes a little bit later than therefore and perovskite tandem is still in the pilot, let's say, in the pilot phase. We see that coming into there, the mass production in around 3 to 5 years from now on. What makes the heterojunction technology so attractive? First of all, it is a mature technology. It is developed in the 80s. Yeah? The process steps are known. And also, it is right away there a bifacial cell concept. And this, you listen here, there also then therefore on the module side, a lot of bifacial cells are coming now more and more into the market, yeah, to generate just more electricity and having a better LCOE value. And here the technology is right away serves exactly this kind of demand. Another thing is also what is interesting is for the Indian market where you have their high temperatures. So the losses of efficiency is here in the high temperature there as small as possible, because it is a combination out of a thin film technology, which is there with a low temperature coefficient, they're always beneficial, and a crystalline technology, they're together. So it is a combination out of it. So this has there an outstanding performance in the utility market, and that is also there interesting for that part. Also, it is a premium product. So you have here really there to the Chinese mainstream, they're also there in differentiator. But the most interesting thing is, and I will show that there also, is that you have there for the cell process, especially in a country which have there not so much there the infrastructure, the training levels of the people in the crystalline photovoltaic manufacturing part, the less process steps, because you have only there 4 processes. You have there the cleaning, you have a PECVD process, a PVD process, which we are doing then therefore, and the screen printing process. And then you have there a very high cell efficiency on that crystalline cell. And it gives you also the capability to upgrade that technology to the future technologies like the perovskite tandem. So what are the drivers in the cost of ownership? Really there to have your screws on it, yeah, to optimize the cost of ownership. One thing is thinner wafers. The heterojunction technology loves thin wafers, yeah, so 120 micron, 100 micron, yeah, and below of that. Yeah. You have the possibility with equipment manufacturers like von Ardenne to have here really there a scaling in the production, so that you have there equipment in the gigawatt scale. So this reduces also there the costs. Companies like Rena, they were focusing very strongly there onto it, yeah, to reduce also there the cost in the wet chemical part. The PECVD guys, like Applied Materials, for example, they invented also then technologies for the micromorph silicon deposition in the PECVD in their equipment to have higher cell efficiencies. From our side, for example, what we are looking for is that you are not using indium in the target material, because we are using here normally the ITO material. And this material you want to have then an indium-free material, because indium is very expensive. And to develop here there the layer stacks, which fits also there to the module technology, this is one other part. Then the metallization guys, which are making there the grid on the cells, they are trying to reduce the silver paste as much as possible, as well also to replace the silver with copper. Then also there in the module side, it is also that companies are using no bus bars, yeah, or shingle technology to reduce here also there the costs on that part. Yeah, and another point, I really want to see this, and also here coming up in India, and this also the government strongly supported, is there also their consequent local sourcing within your own country, so that you have not to import that. But this depends in that case that also that the technology is coming really there on the rise. So when you are taking this into the consideration that you are taking there the screw, the turning on 3 screws, which are the thickness of the wafers, that you are using the ITO material on the rear side in combination with an azo layer, as well also that you're reducing the amount of paste in the metallization and or using a zero busbar technology. Just only these 3 screws will reduce the cost of ownership by 20% on the cell manufacturing side. So this means you are ready all today already to come very close in the cost of ownership in the cell manufacturing side there to TOPCon. And there are furthermore, you can reduce there the wafer thickness close to 120 and beyond, further, smaller. Then you have there also the possibility to use this ITO, AZO also on the front side, or consequently, you will see this also within the next 2 years, that copper pastes are really pushing into that market, which are replacing the silver, as well also that you see then therefore platforms, equipment platforms in the gigawatt scale, on the texturing side, on the PECVD side, on the PVD side. And this reduces that cost of ownership further and brings there more competitiveness there to the product itself. Here just only there very shortly there the summary then therefore what we are doing. So an efficient use of the target material so that you go up to 90% of the target of the tube target material are really then sputtered, and or that you are using their lower cost on the TCO material. Use also the AZO and IZO, what I told you then therefore already there before, and then also there the GigaNova, which is a tool which is really there in the gigawatt scale, yeah, with the high throughput of 1.5 up to 1.5 gigawatt in principle on one PVD coater. Here I showed you there before this morning there also how an inline coater works. I'm very happy that you will be there really an audience which fully understand there also how an inline coating is working. Yeah, and this we discussed already then. Therefore, how a carrier comes from the atmospheric way into a vacuum and then how it getting it deposited from the bottom up or from top down. So as I told you then therefore before, we have there the platforms are available. We are marketing these platforms. We are offering it there to the market, not only there for the heterojunction technology. The same platform are used also for TOPCon. The same platform will be used also then in the future for the perovskite tandem technology. So this means when the technology is ready for upgrading to that kind of technology, yeah, the platforms are already there, existing. When you are asking us, then also, Dirk, is von Ardenne able to support us on our path to a heterojunction cell manufacturing plant? Yes, we are. We have their partners at our site. We have their technology supplier like the Fraunhofer ISE or the ISC Konstanz with us, which are supporting this kind of path. Then also there from the equipment supplier side as well also that we are taking over there the line project management and being from the beginning of your line for a line design engineering down to the line acceptance of the whole plant, we will be there, your partner at your site. Now, how to upgrade that kind of technology there to perovskite tandem? We were talking about it. I showed you there also that normally the perovskite tandem technology are 5 layers, and that we developed there also a line evaporation source, which is very important. You know, the perovskite tandem technology works that 2 layers, for example, the perovskite and also the ETL layer itself can be deposited by wet chemical solution or by vacuum solution, by evaporation. And what we are doing, we have developed here a vacuum solution, therefore, for that, with this line evaporator. And this is a layers, or this is a configuration of a GigaNova, then therefore for the ITO coating, which is there the process number 3. Yeah, so with the ITO on the bottom side and the ITO on the top side, and when you can convert that the same equipment here on the top side for the perovskite tandem, in that you are just using different target material in the same coater. So you are not changing the coater, you have there the same coater, and then you need only an additional equipment for depositing the perovskite absorber, the ETL layer, as well also there the TCO layer. as additional equipment, but you have already that equipment there. The beauty between for the heterojunction is there also that this perovskite tandem technology, like very much there the colder metallization processes, or need this kind of colder metallization processes. And heterojunction is using already that kind of technology, so the upgrading, the modification to that technology is very simple within there, the heterojunction technology. So here, just for the people which were not at this moment then in the speech of this morning, I just show you there also then there the way how the sputtering and also there the evaporation in such a coater looks like. You have here there the carrier where the wafers are laying on, and then the carrier is running in the line. You have there the sputtering from top to bottom onto the wafers, as well also from the bottom to the top, so on the other side itself to get there coated. And we developed here there the evaporation sources already there for mass production equipment up to 600 megawatt, where you evaporate this kind of organic or the perovskite layers by an evaporation process. Thank you, and if you have any kind of questions, please.